as you guessed, I'm French, so I have an accent and I might be hard to understand at some point. Feel free to let me know. I also know that I tend to speak really fast, so same thing, if I go too fast, tell me. My name is Nicolas Rigaud. I'm working for a company that is now called SoftBank Robotics. Until last week, our name was Aldebaran. Aldebaran was created 10 years ago, and all we've been doing is making robots. On my side, I've been working for the last 4 years with developers on paper that I'm going to present, but also on other robots that we have. I'm not a technical guy, so I'm going to do some technical demonstration, but you'll see that the part involving Java is going to be quite short, because that's not at all my specialty, but I'm going to talk about it anyway. I'm going to start this, if it works, with paper. It should work.
Hi Philadelphia, and hello King of Prussia, and Pepper. It's a pleasure to be with you today.
So, I need to get her attention. She's looking at you. Who are you? Who are you? Who are you? Okay. Introduce yourself. Introduce yourself. Okay. Can you try to ask?
Who are you?
No.
Who are you?
It doesn't want. Okay. Emotions? No. Okay. So I'm going to connect to the road. Usually it works at first, and there it doesn't, and it's not just related to my accent, obviously. We are going to do this demo a little later. Then I'm going to just stay on my presentation for the moment. So when you saw that this meeting was going to be about robots, I guess that the first thing that popped in your mind, that's usually the case for anyone, was something that was kind of looking like this, not necessarily with wheels, but usually when we say robots, you think humanoid. That's the first thing. So we are just going to discuss a little the definition of robots. Usually when we talk robot, what people think are humanoid. It means devices that have a body or the appearance of a human. I took this one, he's pretty famous from Star Wars, but it turns out that this one is a toy. And even as a toy, if you were to see it, you would think it's a robot, whereas it's just a toy that doesn't do anything. So there's something important with humanoid. Robots, in fact, are devices that are autonomous and that can make decisions. So it means that if you were to think about something when I say robot, you could have been thinking about this vacuum cleaner that is pretty famous, and that is a robot. Usually that's not the first thing we think about, but robots are autonomous devices more than everything. There's another topic usually that is related to what we discuss, that is artificial intelligence. I put the logo from IBM Watson, but the idea was to illustrate the fact that you expect a robot, this kind of robot, you expect to have interactions with it. And so usually we are also discussing artificial intelligence and how this kind of thing can be embedded on this. So it's not just about hardware, but it's also about software, what I'm presenting. What we try to do at SoftBank Robotics is at the cross point of these three topics. And the reason why we do that is because we think that robots are, in the end, interfaces. Interfaces to interact with machines. You can see that over time, these interfaces have changed, they have evolved, and the idea was to have interfaces that would be as simple as possible to handle in order to control machines. And even though we made all these machines as simple as possible, you still need to learn a bit how to use an interface. You still need to understand how it works, and that's not necessarily easy for everyone. What we try to do with robots is to build something that would be the ultimate interface. We say the ultimate interface because to interact with robots, at least that's the vision that we want to promote, there would ideally be nothing to learn. You would just talk to the robot, and the robot will be able to answer back. You wouldn't have to learn how to say something to the robot because he's going to understand this and not that. The robot would be able to understand what you mean, what you are saying, globally the context of what you say. That's what we try to be. And this doesn't rely only on words. When you ask me something, if I had a good evening yesterday, for example, if I say yes, and if I say yes, that's the same one, but I'm not expressing the same idea. And we want robots to be able to understand this kind of differences. So it's not just about, I'm speaking too fast. Oh, a microphone. Yeah, maybe.
Sorry to interrupt. But
No,
I
that's...
think maybe this might help everyone else as well.
Okay.
Assuming it'll work. Good test.
One, two.
Like, it's not reassuring, is it? Okay, well clearly they don't want to be able to hear you.
There's a link with a robot.
Batteries? Okay, yeah, we'll go and mug a Roomba and get a battery for it.
I try to speak louder. So what was this? Yeah, we want the robot to be able to understand this kind of differences. So not just rely on word, but really rely on understand sentences, context, and ideas that are behind that. So robots are interfaces to robot. I can usually talk to the robot and ask him, for example, to raise a arm or do something like that. So that's a way for me to command this specific piece of hardware. But it turns out that this robot usually is also connected here with a wire at this moment, but we also get Wi-Fi on the robot. So it means that it can connect to other devices and that it's an interface that you don't have to learn to other devices. Here you get the same vacuum cleaner, but we get beacons, we get connected bulb lights. Want to try? Yeah.
We're doing a try, yes.
1, 2, 1, 2. Yeah? Okay.
Yeah. Excellent.
Working. Okay? Yes? That's good? Okay.
Better?
Better or not? Yeah? You get the feedback? Okay, cool. So interfaces, the robot is not just an interface to himself, but an interface to other devices that it can control, and also to services, to online services, to software, to other elements like that. I was discussing just before the beginning of this talk. Usually we have questions like, will robots be able one day to clean the floor for me? And we don't think that the robots we build are designed to perform this kind of thing. That's not what we try to do on our side. And we get the feeling that that would be wasting a lot of time of our engineers to make sure that robots could handle tools that have been designed for humans. So the use case for the kind of robot we would make would rather be, in the morning I'm going to say to the robot, okay, I'm coming back tonight at 6 p.m. for example, I want the floor to be cleaned and the windows to be closed. And the robot is going to connect to the Roomba and explain to the Roomba what is the room that needs to be cleaned, and connect to your home automation box, for example, to make sure that the windows will be closed at the requested time. So what we do is not the robots that are going to perform tasks for you, but rather the one that you want to interact with, and that can be kind of the controlling the rest of the ecosystem of devices or of services, your digital life, and so on. So that's the ideal companion robot we want to interact with. What is interesting for us with this design, it's kind of complex to build a robot like that. This one doesn't have legs, but we have others with legs, for example. So usually they are easiest way to build a robot. But the interesting part is that usually with a design like this one, technology tends to disappear. We have another robot, which is this one called Nao, that is about 60 centimeters tall, so that's about the size of a 2-year-old kid. And sometimes I'm doing demo, the robot is on the floor, and I'm just kicking him, and he falls on the floor. And people look at you like you're doing something that is really, really bad. And in the end, I'm saying, if I was to do the same thing with a toaster, for example, nobody would say anything, and that's a piece of plastic. But because of this design, you tend to project more. Technology tends to disappear. You obviously see that Pepper or Now are not humans. But for your mind, that's something a little that's more than just an object. And that's something that is really interesting for us to take advantage of in terms of engagement. So that's what we do. We have these 3 robots at the moment at SoftBank Robotics. I have to get used to use the new name. Now that I was talking about, which was the first robot that we built. It's been on the market for the last 8 years, and it's mainly addressing the academic market for kids to learn how to program or do everything that is related to STEM, science, technology, STEM. Okay, to STEM. We also have an interesting use case with autistic kids, for example. Romeo is the biggest one, the second robot we started building. It's still a work in progress, but this one basically was supposed to be designed to help the elders and to keep them at home rather than have them sent to retirement houses. So since this was the purpose of this robot, the approach was completely different with the other from the beginning, specifically in terms of hardware, because on Romeo we have this flat part here is because the robot needs to completely be able to bend to grab objects on the floor, and so that's the first one that we designed that has a spine that allows him to do this kind of thing. And then the last one that is Pepper. Pepper has been on the market for the last 2 years. It was only available in Japan. We sold something like 20,000 copies of this one. The idea behind this robot was to be able to have a platform that people would engage with in in retail stores at first. SoftBank, that owns our company, is not a bank, but on the contrary, that was a software bank. So they are a telco operator in Japan. They own Sprint in the US, for example. And they wanted to use the robot in shop to face and interact with customers. So they asked us to design a platform for them. That's the reason why we have wheels on Pepper, because it was easier to handle moving inside of a shop with wheels rather than legs that are more unstable. That's also the reason why we've been able to stack a lot of battery and the robot can operate for 12 hours. And that's also the reason for the tablet, because we are still a civilization that is based on visuals. There are things that we need to see that are easier to see than to listen to, and the tablet is really useful for that. So that's the kind of robot that we are designing. All of them are running on the same operating system. So it means that if you create an application for one of the robots with a little fine tuning, the other robot should be also available to run them. A quick view on the technology behind the robot. So for Pepper, a few elements I was mentioning. So we have a battery processor on the robot. We have Wi-Fi and Ethernet. 20 motors. So it means also that we have 20 degrees of freedom on the robot. It's 4 feet tall, 62 pounds. And the battery can last for 12 hours. In terms of sensor, I'm going to present them on the robot, then I'm going to display. So we have speakers here. You saw previously the picture I was showing when there was like technology tends to disappear. That's funny, the kids were talking to the speakers because that's where their ears are for humans. So you see that they project more than the hardware. The microphones are here, in fact. So they should be talking like that to say secrets. So we have 4 microphones around the red, directional microphones. So the idea is really like to have a focus on someone at the moment the robot is looking at you, for example. And so the microphones are really there to be able to grab what you would say to the robot and to avoid having perturbations from the rest of the people talking around there, for example. The red dot in this eye, we have a 3D camera that allows the robot to sense depth and to take advantage of this. We have 2 2D cameras that are here and here. So usually people are expecting cameras to be in the eyes. They are here because that's something that is existing from the first robot we designed, and our first client was the RoboCup. If you're not familiar with that, the RoboCup is that's a competition of soccer between robots, and the goal for the organizers is to make sure that a team of robots would beat humans by 2050. So at the moment that's robot versus robots, but I hope to also face humans at some point. And the reason for the cameras is because they needed to monitor at the same time close to the foot so that the robot could shoot the ball, and at the same time to monitor the whole field to see where the other players were. So that's the reason for the cameras. We have a tactile zone on the head with 3 sensors, so I have different zones on it. We have the tablet, we have a gyro in the torso, we have tactile zones on the hand, and we also have lasers on the base of the robot, so as to be able to detect obstacles around him, and a few sonars too that are available. So the loudspeaker, the 3D sensor, the microphones, and the tactile sensor, plus the 2 cameras, the tablet, the gyro, and the tactile sensors on the hand. I'm sorry that the image is a bit bright like this. And the laser, the sonars, up, and the safety bumpers that are these elements in case the robot doesn't detect an obstacle. At the moment it's going to hurt it, we can still feel it here. So since the robot doesn't go that fast, usually that's enough if he's not been able to detect an obstacle for him to detect it in the end. From a software point of view, we have our own OS, so we can debate on what is on OS, but that is called NeoKey. NeoKey is based on different services. We have here IL memory, for example, that is going to handle every data that you want to store on the robot and take advantage of a little later. Motion is everything that is related to movement, so we have a walking to, angle interpolation, different elements like that. AL LEDs for the LEDs in the eyes, for example, or around the ears, and so on. So we have a lot of services and with different methods in order to send or get data from the robot. So that's really basic in terms of architecture. We have something that is running on the robot that is called also the autonomous life. The goal behind the autonomous life is to make sure that the robot will be able to understand the context and what's happening around him. So we are using all the sensors available in order to grab data and be able to understand what is happening. All this data is going to be sent to what I call the contextual artificial intelligence, that is in fact making decisions regarding what application to launch at this right moment based on what the robot knows about the context. And once, so it also means here that basically what we provide is an empty platform. We had an OS running on the robot, but if you come and talk to the robot, ask him anything, he is not going to react. Basically, it's a platform, and you still need to run application and run them on top of our OS in order to get the robot to do something. He can understand, for example, English, but it doesn't mean that because he can understand, he understands the purpose of what you want to say. So if I ask him to go grab me a Coke, for example, if there's no application where the robot understands what that means, then nothing is going to happen at this point. So we are really relying on applications. We have a store that allows you to download application on the robot. And once we have the robot understanding what is the context and paying attention to what kind of application he could launch at this point, what is triggering the launch of applications, we have execution on the robot. So in that case, we have an application that is called, for example, fist bump. The robot is going to detect this, and then you can play fist bump with him. So that's really easy, I mean, in terms of architecture, how it works, but this makes it quite easy, I think, to understand. If we look at this from a different angle, that's the exact same thing. We get the input services that are going to help the robot understanding the context. Then this information so we have, of course, some services that are always running on the background and that can take the lead in case of emergency on anything else that is running on the robot. If the robot gets too hot, for example, he's not going to perform all the movements you're going to ask him to because it could break at some point. So he's going to refuse executing what you ask so as to prevent damages on the hardware. So we have a few systems, a few services running in the background, navigation, being stable, and so on, keeping its balance. Then we have all the activities that are installed on the robot. A set of them are selected as being relevant in that specific context. Then we have some prioritization, selecting which of these applications makes more sense from those that are relevant. And then we have the execution on the robot that is taking advantage of the output services. So all the motors, for example, the text-to-speech, the motors, that's for the animation, of course, the sound, the LEDs in the eyes, or anywhere else. So that's really the way it works. In order to program the robot, we are not going to ask you to learn a new language. That would be stupid. So basically and natively, that's Python that is on the robot. what we provide at first is a software that's called Choreograph. I'm going to make a quick demonstration of Choreograph. The way it works, we have here a main plane where we are going to design our application. We have here a representation of the robot. If I'm connected to a real robot, just like now, I should have a feedback of the robot I'm connected to, else I just have a simulator. And here I got a set of boxes that I can use, and each boxes are going to perform a specific action. I drag them onto the main plane, connect like that, for example. I click play, and it's going to run on my robot. So that's pretty easy to do. If I double click here on these boxes and look what's inside, you'll see that's Python code. So I'm going to. It's not coming on this screen. How come? Any idea of how it works? I don't get the. I just have the PowerPoint. In fact, maybe I should quit PowerPoint. Let's see if it works. Okay. Okay. So, is it big enough for you to see? No, not really. Okay. So here, I don't think I can zoom a lot on this. I will try. Better? Yeah, a little. Okay. So I'm going to connect to my robot. And to play what I wanted to show you before. So you might have seen this green dot starting here. So the boxes on top, the first one is called wake up. That's going to wake up the robot, turn on the motors and so on. The second one is called breathe. So the robot is going to have these small movements from the torso, so you don't think that it's completely dead. And we have another one, blink, and basic awareness. Basic awareness is the reason why he keeps looking at you, because you're the first face that he can detect, and he's keeping the focus, keeping the focus on you. You know, we can discuss after that. I think that's one of the reasons why I like robotics that much. It's because it really asks questions about who we are as humans and how we interact. The more you work with robots, the more you realize how intelligent we are without even thinking about that. And for example, here the robot keeps looking at you because you're the first face that he can detect. He's not going to listen to anything, so you could ask, usually, you could ask him to take a break, for example, and he would just go away. But
does it mean that I keep looking at him?
no, not necessarily. You can do what you want. Before we had that, so the robot was detecting a face. You start talking to the robot, then you do a few steps aside, and the robot was still looking at an empty space because he wasn't tracking you. So now we start tracking, but you can see that there are limits to that it can make people a little uncomfortable because he keeps looking at me. So we're discovering. You'll see it's not that bad, so it's gonna stay here close to me. But I mean, that's interesting to question this. That's what's gonna be at stake when creating application for robots. That's all these elements, how people behave with robots. And you're gonna see that there are, I'm gonna talk about that a little later. There are great things to take advantage of with this kind of platform. But anyway, so at the moment the robot, he's playing like that. So you just this line allows him to give you the feeling that it's not there. But it's doing nothing, he's not going to react to anything except the face and track it. But that's all. Here, I built a new entry point that is going to start the rest of my application when I touch the head of the back of the head. So it's going to say hello Philadelphia once again.
Hi Philadelphia, and hello King of Prussia, and Pepper. It's a pleasure to be with you today.
Who are you? Who are you? Tell us about your software. Can you try?
Who are you? Tell us about your software.
Yes, sure, all SoftBank Robotics robots are powered by the Now-Key platform. Now-Key is fully programmable with both Python and C++ through an integrated development environment called Choreograph, a suite of visual tools that allows developers to create rich applications.
So I'm going to play the Who Are You? Because I can send from right. Oh, it doesn't start anything. Can you try to introduce yourself? Introduce yourself.
Hello, my name is Martin.
No, ask me to introduce yourself.
Oh, I'm sorry.
No. I wasn't clear, that's my bad. Sorry. No, just telling me to introduce yourself.
Please introduce yourself. Please introduce yourself.
It doesn't work on this one. So, there's something I wanted to try, so I hope it's going to work. Eva? Oh, there's the light behind me. Okay. Guess my age.
Well, I can try. I could not guess.
Guess my age.
Well, I can try. You're 43 years old and you are a male.
Well, you can try to do the same. I'm going to.
She ain't gonna do that.
It's tracking you. But if someone can come and try to catch the attention of the robot and do the same, guess my age. Anyone, just come.
That's my age.
Well, I can try. I could not guess.
Try to come a little closer.
Guess my age.
Well, I can try. I could not guess.
Maybe that's the light on you. So, no, stay. I'm going to just be here.
Please guess my age.
Well, I can try. You have 23 years old and you are a male.
You're buying that, aren't you? New robot for him.
I hope you see how good it is for the ego. So that was one thing to try this. Then I'm going to try something else. Eva? How do I look? How do I look? How do I look? What's my mood? Okay, so that's the accent. Someone can try. I think that the sentence should be, how do I look? Someone can try? So you need to catch its attention.
How do I look? How do I look?
So it doesn't work. Stay there. I'm going to try to start.
I have evaluated your mood to neutral, just like Switzerland.
Try smiling.
I have evaluated your mood to happy. You look like an idiot when you smile.
That was supposed to be for me, so.
The Hello King of Prussia. I'm Pepper. It's a pleasure to be with you today.
So, okay, Pepper. The idea behind that is to say that basically what we were providing to developers was the access to the raw data from the sensors. Hey guys, you got an access to the video camera, to the video stream, and help yourself. Now we provide directly APIs where you are able to take advantage of this kind of thing, telling you what's my mood, what's my age, what's my gender. That's just a box if you use Choreograph, and that's just APIs with calls to make. So it means that you don't have to rewrite everything from scratch. You can already take advantage of this kind of element. Here, that was kind of funny, but there are elements like that that are going to give you the feeling that the robot is smart. it doesn't. I don't have a real example for English, for example, but in French, you know that we have words that we, for adjectives, for male and female, they are going to be different. If the robot can sense that you are not a male but a female, it doesn't work on male because everybody is usually for male. So, but for a woman, to see that the robot is able to understand that she's a woman and that it speaks to her as a woman, even if the robot isn't integrating a lot of artificial intelligence, it gives you the feeling that it's intelligent. For example, when the robot can sense the age, of course he made a mistake. The idea is not to be sure that I am this exact perfect age, but rather to say, okay, if that's an elder, I'm maybe going to use a polite way to express myself, rather than if it's a kid, where I can be more familiar with the kid. So the idea is not just to say, hey, we managed to have data, but to use this data in order to enhance the interaction that you are going to offer to people interacting with the robot. So that's really what we try to do. Take a break. Have a break. Have a break.
Have a Kit Kat.
Yeah. So we can maybe take this. Yeah.
Front slide.
So of course, all of what I was saying is scripted. Usually people are a bit disappointed, like, okay, but the robot is not thinking by itself, he's not answering my questions for real, and we could do something like that. In the US, IBM is using the robot and integrating Watson on it in order to be able to have more natural interactions with the robot. Our approach is more to say that since the robot is more used by companies want to keep control over the kind of interaction they are offering. We have a supermarket chain that has been using the robot in France. I'm not sure they'd be really happy if people were to start discussing politics with the robot and the robot giving its opinion, for example. So the idea is not that you cannot integrate artificial intelligence software on the robot. It's more that our approach is to say we give you the choice, and here what we provide is a way to write for the robot. So maybe that's not the best thing to show. So just a second. So what we do usually is that we write topics. Topics is the name that we give to the elements that are related to dialogue. And here's an example. Is it big enough? I cannot make it bigger. Is it easy for you to read? Almost. I'm going to explain a bit what's here. Here, we had the very basic element of a conversation with the robot. Here, I'm just declaring a rule, and I'm saying what's between brackets. That's what the robot is looking for, what he's hearing from the human. And after the bracket, you get what the robot is supposed to answer. So, first case, I'm saying hello, and the robot is answering back, hello human. Cool. But in real life, it doesn't work all the time this way. If I am to come and say hi to the robot, then it's not going to react because I just programmed on the first line for hello. So we have a way to integrate these different elements that try to convey the same idea. Yeah, I can say hello or hi to the robot. And in that case, I'm going to put square brackets, brackets and square brackets, and add the two words that I want the robot to recognize. So whether I say hello or hi, the robot is going to answer hello human. The next step, I'm not necessarily just saying one word. Maybe I'm going to say hello, hi, or good morning, good evening, whatever. And I can also take into account these cases. Then I'm using, how do you call them? Commas? Quotes, sorry, okay. Then I'm going to use quotes when I have several words in order to say what you pay attention to is this one word, or this one word, or those two words, this expression. And then I still have a feedback from the robot that is going to be hello human. I can go a little deeper. Hello, hi, but sometimes, even if you're supposed to say good morning, you no longer say good, you just say morning. And so I can use this. So I don't know what's the name, it looks like this.
Curly bracket.
How?
Curly bracket.
Curly bracket, okay. So you can use curly bracket in order to say to the robot, okay, this word, it might be optional. You might hear good morning, but maybe you're just going to hear morning in that case. And then you should answer hello, hello human. in this input, I can also add events. If I'm completely hidden, for example, and I say hello to my wife, but the robot is still able to understand, to hear me say that, he's going to react whereas I'm not talking to him. So I can add an event where I ask him first to have a face detected, and then to hear the word hello or anything else before giving me a feedback. And then I can also add different elements to the answer of the robot. That's an element I'm going to discuss, but if you play video games, there are usually these non-playing characters. And after talking to them about 5 times, you see that there's a small loop, and that they always say the same thing. So if I am to say to the robot, hello, hi, whatever I want, and he's always saying, hello, human, it's going to be boring quite soon. So we can add for the robot just the same way that we write this syntax in order to define what he's going to listen to. We can use the same syntax in order to define how the robot is going to talk. We can add some randomness, for example. Here he's going to read it as a series. The first time he's going to say hello as a feedback, the second time hi, the third time good to see you, the fourth time he's going to start again here. So we can ask him to use randomly an element of this list, and this list can be as long as you want. So that's a way for us to create rich interaction, but it also means that we have to think how humans are handling dialogue, conversations, and things like that. So that's the interesting point. You can also use sub-rules, for example. Here the human would say, for example, let's talk about animals. So the paper would answer back, do you have a cat or a dog? Then I can give a sub-rule, U1, if I am to say dog as an answer. Or another U1 if I am to say cat, or another U1, for example, if I say, none, I don't even have a dog or a cat. Yeah?
Will it pick that word out of a sentence? So if I say, I have a dog, in response?
No, if you want to say, I have a dog, for example, you would have to use the same syntax here to, just make sure, for example, it's not sure that you're going to say none. Maybe you're going to say, I don't have any of them, or I don't like pets, or there are many ways for us to answer. That's another element I'm going to present after that, how it's easier for developers to create robot-driven application rather than let human guide the interaction, because it's going easily to be disappointing. So you need to use the robot in order to drive humans to this point or this, not let them too many options. So we can use sub-rules and sub-rules and so on. So there are really interesting ways to handle this. And the last example I was taking is how to use inputs that come from what the user is saying. Here we have the robot. So proposal, the robot is not waiting for someone to talk. He's the first to talk. So I have this proposal. Oh, that's my screen. So here what we have is this proposal. The robot is going to say, what is your name? Then what I write here is the robot should hear something like my name is plus something, and I can ask him to remember this something and to use it in his feedback. He's going to say nice to meet you. The $1 is going to reference to this part. So the tricky point is, did the robot hear correctly your name? Maybe not. So that's going to look strange after that. But there's a way to handle that. If that looks strange, maybe you're going to laugh and the robot can detect that. So detecting that someone is laughing after this, we could say, oh, maybe I was wrong. So that's how we use all those things, the reaction from people, take advantage of the sensors on the robot. It's not going to work all the time, but it doesn't work all the time between humans, and there are ways for us to make sense and deal with that. So that's how we write the dialogue. There was another part that I wanted to show you briefly, and I think I need to be disconnected from my robot in order to show you. So, okay, I'm going to launch it again.
The tablet on its chest is very psychedelic.
Is ready?
The design, the animation on its chest is very psychedelic.
Yeah. You shouldn't watch it for more than 20 minutes, else it really gets bad. Be careful with that. No, what I wanted to show you, is another element. So I'm not going to teach you how to write code in Java and everything like that. There are two elements that are really important with robots. The first thing is the dialogue, the way our vision of the dialogue. It means that you have to write everything, and so that's really important. And we're providing, I was just presenting a few examples, but we are other ways to handle other situations. We have linguists working at Aldebaran, specifically Aldebaran, at SoftBank Robotics, specifically to design how the dialogue should be written, the big architecture and so on. So that's really something we take seriously. But the second important element on the robot is, of course, animation. Quick sum up. Hello, I'm fine. Nobody's interested when the robot says, hello, I'm fine. That looks a little cool. That's more cool. So how do we do that? We can create custom boxes, which is what I'm going to do, that we call timeline. So this one we're going to call it test. And the timeline, that's something that looks like that. So if you have done a bit of 3D animation, what you're using is a timeline. And you are going to define keyframes for what the robot is going to do. We have 20 motors, but we can use just some part of it. So for example, how can I do that? Is it better? Maybe I can just... Okay. So for an animation, I can just click. But I think I closed the bar. I was in the middle. In fact, usually when I click on the motor, it's not happening. Yes, it is. So here, for example, you can see that I can move the head. I should be able to. Oh, it moved just a minute ago. I'm not really good at grasping this. Oh. Okay, I'm not going to fight for hours with my mouse. You can click on the motors. Usually you can see the axis that you can use with the motors. What we do is that we are going to define a first position. Usually not from the very first. So 25, that's for 1 second, 25 frames per second. So usually we don't start at the beginning because the robot could be in a position and it's going to take some time for him to go to the first position you're going to ask him to. Let's say that, for example, I want the robot to wave at me. We know that the first movement cannot be the robot is like that, because if he was like this just before, it's going to be impossible for him to be at the same place at the same time in two places. So we let some space at the beginning, and then we can say, for example, in order to say goodbye, the first thing to do will be to raise the shoulder, then this part, and then the first image will be like that, the second, the third, and the robot is going to do all the interpolation and so on for you. So you just define key elements with a physical robot or with the simulator, define the keyframes, and then you can play it. That's how we build, we design animation. It looks simple. It's designed as simply as possible. That being said, all the attention that you can give to animation is what is going to make the success or not of an application. If the robot moves weirdly, for example, people don't necessarily want to engage with it. And even waving at someone, I'm going to show you when I do that myself, and when we have 3D animators doing this, you can sense that there's a difference. So this is for choreograph, the way it works. I just have, and it should work, a small demo of Java. So for Java, what we're providing is just is really an SDK and APIs that you can use. Well, I'm saying we are just providing an SDK. We are all, last week we also released we made the announcement during Google I/O an Android SDK. So for those interested in writing with Android, we are providing something. So let me just take my notes because I'm not really good for this part. So the way it works is that we declare an application, if I'm right, just here. Then we start an application and create a session that is going to connect to the robot. We retrieve the created session. I'm reading my notes. And then here what we do is we get IL text-to-speech on this current session. We set it, we set the language, and we send what it is supposed to say. So here I think that the IP address of the robot should be good. So if I just play this one, right now it should work.
Hi everyone.
And if I touch, so I also have middle tactile. That must be this one.
Over someone is touching my head. Over someone is touching my head.
So pretty easy, you see, that's it, oh, someone is touching my head. So pretty easy to do. You can, of course, also build animation if you want in Java. Usually what people do is that they create animations using our tool. Then the animation is exported as an application and they call it directly from their software, whether it's Java or anything else. But even though you could say, okay, for this motor you are going to take this angle and so on, that would be a lot of pain to do that in Java when you can take animation directly from choreograph. So that's the way we recommend you to do that. But so I'm not a big specialist, as you guessed, but I'm going to present it after that. All the software is available for free on our community website. So if you want to have a look at the APIs, there's all the documentation and so on. Feel free to do so. We have a simulator where you can test your software for the things that you would create. So if you want to have a look, really feel free to do so. I'm getting back to my presentation. That's it. So I was just here saying that we have choreograph. Yes, we have choreograph that is available for Windows, Mac, and Linux. The resources, why do we have this in the middle? Okay, so we have a Java SDK, JavaScript, Android that was released last week, C++, and Python. The resources we are providing, so I was talking about our community website, that's developer.softbankrobotics.com. The software is available, all the documentation, Q&A, the forums, and some community events. We are going to organize more and more hackathons, even across the US. Paper should be available, kind of not freely, but it should be easy to order before the end of this year. At the moment, we are looking for partners who are interested in building or adapting existing solutions they have to use them on the robot. So I cannot give you an exact price at this point. I cannot tell you when the robot is going to be available, like even ordering it online. At the moment, it's better to be directly in touch with our business teams. But if that's something you're interested in, I'm not the good person for that, but I can connect you with the right persons. What we try to provide is not only our OS and the tools in order to program for the robot, but also a store. At this point, it's really more a distribution engine where you can manage fleets of robots and so on. Most of our clients, we have the developers on the one hand, but on the other hand, we have people like SoftBank or other companies that are using the robots in supermarkets, for example, and they want to be able to deploy applications on a bunch of robots. So we are providing the tools in order to handle this and make it as easy as possible, so you don't have to connect physically to every robot and install the application on it. And then we're also providing a few analytics, though the developers that are working with us are usually integrating their own analytics to the application and doing the improvements by themselves, but we're also providing a few things. A few use cases, because sometimes people ask us, but okay, that's nice, that's cool, but what do people do with these robots for real? So the first client we had was SoftBank. SoftBank is using the robots in his shop in order to interact with people. When I say interacting with people, that's mainly playing small games, doing some dances and things like that. That looks kind of funny, but remember that SoftBank is a telco operator. If you have, at the moment, your phone subscription at AT&T, the chances that you visit a Sprint shop or one of the competitors of your provider, the shop of one of your the competitor of your provider, are really small. Thanks to Pepper being in shops in Japan, they managed to attract a lot of people who are not clients to their shops, and then engage with them with, of course, salesperson. So the robot was more there in order to attract people. That's why the usage was really dances and small games with the kids. But anyway, they had a really interesting feedback regarding the increase in traffic in their shops and how they managed to transform that into money in the end. The second client was Nestlé. Nestlé is using the robots in order to, there are some shops where they have corners and there are no human managing those corners. So as a client, you come, you might be interested in buying a coffee machine, but maybe you're not and you're going away. They are using paper in order to catch your attention. Usually you get closer to the robot when it gets your attention. And after asking a few questions, the robot is recommending the coffee machine you should buy and the kind of coffee that is perfect for you. That's nothing really new. You could have the same on your mobile phone, on a tablet, or anything like that. The thing is that I have never seen a tablet waving at me in a shop and asking me to engage. That's what's interesting with the robot. It's not that doing a poll or a recommendation based on questions is so hard. It's just that the platform is more engaging than what has been provided so far. So for them, that was really interesting to do that. If you look online, I made a report like last year because I was in Japan, and showcasing this application was part of this report. One of the there's also some elements of entertainment coming with this application that they did, and there's something that seems to be really funny for people in Japan. They have sentences and they ask the robot to pronounce these sentences, so you can choose on the tablet from 1,000 times to 1,000,000 times faster than usually. So it seems that they have a lot of fun listening to the robot talking in a way that they cannot understand anything, but they like it. So that's funny. There's a big cultural difference between what people expect, I guess, in Japan and what you would expect here from an interaction with the robot, but this is definitely one of their hits. I was mentioning the fact that in France there was a supermarket chain using the robot. This is Carrefour. Carrefour, what's interesting, so I made a mistake on my slide. It's not 35 stores in France, it's in fact 35 robots in France and Spain. And it's 35 robots that they are using in 7 shops. It means that they have 5 robots per shop, and so they have 5 robots performing a different task. And this is where it gets really interesting. There's something that is, I was going to say, quite basic. I don't want to be rude, but like doing recommendations, for example, for the loyalty card and things like that. But there's one job that they gave to Pepper that for me is really interesting, is the job of wine advisor. And it turns out that in France, if you know nothing about wine, you're never gonna go to a shop and ask someone to give you advices. For one simple reason, because they're going to judge you. That's really that. I mean, you're supposed to know wine as a French guy. So, and when you go to the robot for the exact same thing, the robot is not going to judge you. And that's a really interesting element to take advantage of. Another element to keep in mind that is interesting in this kind of cases is that sometimes people complain like, okay, but is it what we deserve interacting with robots rather than having humans to interact with? And you can see that sometimes interacting with humans means that there are ways to do that, that you need to be polite, for example, that if you spend 15 minutes discussing with a sales guy, that's really hard for you to go away at the end and buy absolutely nothing because you wasted this time. So there are things like that when you interact with humans that are kind of awkward sometimes. With the robot, you can not be polite. You can come, ask a question, and go away without saying thanks, and that's fine, because there are moments where you want interaction, where you want to spend time with people and discuss. There are other moments you just want to go straight to the point, get the information you're looking for, and that's all. So the idea for us is not to say let's replace all humans with robots, but rather to think how robots can be complementary and be good at some things where we are not necessarily good on our side, and let us handle what we are good at if they are not on their hand. So these are a few. Yeah, that's one of the jobs. Another job of the robot is to do polls at the end of the when people are queuing before paying, and also to do some receipts. Carrefour is trying to sell some old-fashioned vegetables, and people don't buy them because they don't know how to cook them. So the robot can get your attention, can get you to come close to those vegetables, and can also give you recipes, for example, things you could cook with these vegetables if you buy them. So that's also a different job that they use the robot for, but that is interesting because it solves a problem that they manage to identify. People don't buy because they don't know what to do with it. SNCF, that's the French National Railway, that is using a company that is using the robots mainly in order to give directions to people when they are coming to stations, or things that they could do if they are arriving at the station and visit in the neighborhood. You'll be there for half an hour, going down the train and waiting for the next one. Maybe you can take a walk in the surroundings. Here are the places you should visit. Here where you can go to have a drink. This kind of thing. So that's really interacting with their clients, not necessarily using the robot so as to sell something, but really more to provide services and information to the customers. Another point, look how great it is. This is Japan. They love customizing the robot. There's always a hat or some thing that he's wearing that's really lovely. Here they are using the robot so as a cosmetic advisor. Once again, same idea. These are things that could exist on a tablet, on a screen, or on any device, but it's less engaging than having the robot. Here it's connected to their Q&A, so the robot can take advantage of the elements that they have already to answer questions. And yeah, the interesting point is that at the moment, we've been able to monitor more than 500 interactions by day for each robot. So it means that maybe there's a cultural difference that makes it easier for Japanese to go to robots and interact with them. But anyway, the figure is quite impressive because 500 people a day, imagine the number of humans it's also taking, and here you also have always the same relevant answer, whatever the case. As long as it's the same answer, you're going to have the same feedback. So I was mentioning the people that are using our robots. But when I told you we are looking for partners at the moment, people interested in building application and adapting solutions or things like that, I wanted to highlight the case of these three guys. We are working at the moment with 20 partners in the US, someone who in the US, in Europe, someone who I was discussing with, I don't remember who, I'm sorry about that, before that meeting, was mentioning the fact that Pizza Hut will use Pepper so that you can order pizzas through Pepper. That's something, the proof of concept has been built and presented today in Europe, and in this pool of 20 partners that we are working with to develop solutions, we have these three guys, Franck Calzada, Carl Clement and Xavier Basset. The first and the last one are French guys, the second one is British, and they all joined our community 5 years ago when they bought, all of them, a Now robot, which was the first one that we released. They worked as hobbyists, creating application, events, hackathons and stuff like that for a few years. And last year, 2 years ago almost now, they started, each of them started their own company. Franck is the guy who created the application for Carrefour, for example. Carl Clement was presenting today in Paris because he's one of the partners in our partner program. And Xavier Basset is the one who created the application for the French National Railway. So they are contractors. We are selling the robots, but the robots are platforms. So then, depending on what you want to use them for, you have to create the software, and they do that for those companies because they have experience working with robots. But what I wanted to say with that slide is, we don't ask you at the moment to come and believe in it. When we started the company 10 years ago, there was no market, and it was hard to convince people to come and join us and support it because it's going to change the world. At the moment, these guys, they are making a living out of just building applications for robotics. And the interesting point is that it's not related to the amount of robots that are available at the moment. When you decide that you want to write an application for Android, for example, most of the time you know that you're going to lose money. I remember attending a conference about mobile gaming where people were saying I can expect an income of $5,000 that was in Europe, so 5,000 euros for my application, but it cost me almost 20 to develop them. So each time I'm working on an application, I know that I'm going to have, on the average, a loss. Here, they do that on the for B2B, so it's not about people buying their application for a really small amount. It's companies that have the money in order to pay them. And so even for 35 robots for Carrefour, Frank made a decent amount of money just creating the application, and it's going to get bigger and bigger. This was just for Europe, but we are going to do the exact same thing in the US. So that's it. If you're really interested in robots, feel free to let us know and try to join us. A few elements we learned during these 2 years where Pepper has been on the market is the importance of designing correctly applications. Here, I'm going to talk briefly about the difference between user-driven application and robot-driven. This is the best example of disappointing interaction with the robot. Someone is coming asking the robot, hey, get me a drink, robot. The robot doesn't know at all what that means. So it's just like, I don't know. And for the person in front trying to interact with the robot, he's just going to think, okay, this thing is stupid, I'm going away. If you designed it this way, the robot with the 3D camera is able to sense and detect people. So if he detects that someone is coming to him, then he can start the interaction instead of waiting for the other one to do that. Hey, I'm Pepper, glad to see you. Do you want to do this or that? And then you get the user to choose between this or that. So he's not going to ask something that the robot cannot do. Usually if you are, do you want me to do this or that, you are not going to ask him to do a certain thing. You know that you have to choose between those two. So designing the application so that they are robot-driven, it doesn't mean that it's not interesting. It just means that in that case, it's going to be disappointing for everybody, whereas here, we can handle this kind of situation. So that's really important to keep this in mind. At the moment, it's not an almighty robot, and you need to make sure that he's able to understand the context and make it as easy as possible for him and for the user. So having this mindset is definitely something that is interesting to design application. This is my great moment. I talked about it a few minutes ago. So this is my job. Hello. So you can see I'm an artist. And this is what is done by a 3D animator. I think you get the difference between both of them. Yeah, of course, they're just waving, but you can see that he knows that movements for humans are a bit different.